One scenario says life on Earth didn't begin here. Another suggests the first thing to enter our solar system wasn't a rock, but a hunter. And a third is worse, the universe itself could erase reality without warning. These ideas don't come from science fiction. They appear in peer-reviewed journals proposed by Nobel laureates. They're rarely discussed publicly, not because the evidence is weak, but because the consequences are unbearable. In 1903, Swedish chemist Svante Arrhenius proposed something deeply unsettling. Life did not originate on Earth. Microscopic organisms could drift between stars, carried by radiation pressure, seeding planets across the galaxy. At the time, the idea was dismissed as speculation. Then the data began to accumulate. Amino acids inside meteorites. Microorganisms surviving vacuum exposure in orbit. Biological material detected high in the stratosphere. In 1973, Francis Crick proposed a more disturbing version. Directed panspermia? Life may have been deliberately planted. The genetic code is universal. Life depends on elements scarce in Earth's crust, but common in stellar environments. All signs of a single external origin. If this is correct, the question isn't where life came from. It's who planted it, and whether they're still observing the outcome. Self-replicating machines are mathematically possible. John von Neumann proved that in 1948. Frank Tipler followed the logic to its darkest conclusion. Eliminating future competitors. A single probe could reproduce using local materials, spread across the entire Milky Way in a few million years. Given the galaxy's age, they should be everywhere. Yet we see nothing. They've already done their job. The silence isn't emptiness. It's aftermath. The discovery of the Higgs boson in 2012 revealed something alarming. Its measured mass places our universe on the edge of instability. Our vacuum state may not be truly stable, only metastable, like a ball resting on a shallow ridge. A quantum fluctuation anywhere could trigger a collapse into a lower energy state. The resulting bubble would expand at the speed of light. Inside it, the laws of physics would change. Atoms could not exist. There would be no warning, no signal. Reality would simply stop. In 1999, astronomers studying distant quasars found something impossible. A fundamental constant appeared different in the early universe. The fine structure constant. Later data suggested it might also vary by direction in space. If true, the laws of physics are not universal. They are local approximations. Every equation we trust could only be temporarily valid. True here, now, and nowhere else. In an eternally expanding universe, random quantum fluctuations can assemble anything, even a conscious brain. No body, no history. Just a momentary structure with memories that never happened. The math is brutal. These brains would vastly outnumber observers produced by evolution. Statistically, you would be more likely to be a random fluctuation than a real human. And if most observers are unreliable hallucinations, then all science collapses with them. Advanced civilizations may not expand outward. They may collapse inward. As technology improves, computation becomes smaller, denser, more efficient. Civilizations optimize for information density, not territory. Eventually, they retreat into scales we can't observe, possibly approaching physical limits, like black holes. SETI searches for signals. But mature civilizations don't broadcast. They disappear. All known life depends on phosphorus. DNA, RNA, and ATP require it. There is no known substitute. Astronomical surveys show phosphorus is extremely rare, produced only in specific supernovae, most abundant near regions hostile to life. Our solar system sits in a rare phosphorus-rich pocket. If phosphorus is the bottleneck, then complex life isn't rare because evolution is hard. But because the universe didn't make enough ingredients, every civilization is an armed hunter in a dark forest. Making noise is fatal, even if others seem peaceful. You can never be certain. And by the time certainty arrives, it's too late. The safest strategy is silence, or preemptive elimination. The universe isn't quiet because it's empty. It's quiet because everyone understands the rules. Quantum experiments suggest something disturbing. A system can be definite for one observer, and indefinite for another. Measurements made now can influence outcomes in the past. If observation creates reality, then before observers existed, the universe existed only as probability. That places consciousness at the foundation of physics, not as a byproduct of matter. Earth-like planets are common. Organic chemistry is common, yet spacefaring civilizations appear non-existent. If early steps are easy, then the bottleneck isn't behind us. It's ahead. Technological power grows faster than wisdom. The window for self-destruction is narrow. The silence of the galaxy isn't a mystery. It's a statistical warning. Every discovery showing life is common pushes the filter closer. Not because we are weak, but because every civilization reaches the same point, and very few survive what comes next.